Hi everyone, and welcome to this lecture on chapter 14. So this should be a pretty fun lecture. We kind of get to take a little step outside of the nutrition world and talk more closely about physical activity. And then, of course, we will, at the end of this lecture, relate physical activity to nutrition, basically talk about how to use or how we do use food to fuel physical activity. So to start off, let's just give some definitions as usual. We're going to talk about two concepts here, physical activity and physical fitness, and we're also going to define exercise. So I guess three concepts. So physical activity, think of this as sort of the umbrella term. Physical fitness and exercise both are concepts within this broad context of physical activity. So physical activity encompasses any movement that is produced by technically the skeletal muscles of the body that increases the body's total energy expenditure. So you'll remember, hopefully from chapter 13, that the energy expended by the body includes the energy expended to produce physical activities. So this is basically an extrapolation of that short mention of physical activity as a component of energy expenditure from last chapter. Within physical activity, we also have something called leisure time physical activity. So these are any activities that a person might do that are unrelated to their occupation. So exercise actually falls into this subcategory of leisure time physical activity. So any sort of movement that a person does that is purposeful, planned, and structured, that's what we consider exercise. So exercise is a very intentional form of physical activity. That's sort of what sets it apart within this broad conversation around all movement that we might do. You might recall too, we've mentioned this concept of activities of daily living, which is sometimes abbreviated ADL, activities of daily living. So that would actually be another component of physical activity. These are things like taking your dog for a walk, doing laundry, walking from the parking lot to the grocery store and through the grocery store, sweeping your house or vacuuming your house, mowing your lawn. So those are what we consider activities of daily living. They are physical activities, obviously. They are movements that are produced by the large skeletal muscle groups in our bodies. And then leisure time physical activity are other things that we might do. So any sort of recreational activities like going for a hike, walking or biking. And yeah, these things are, you could say that these are purposeful and planned and structured as well. Where recreational activities differ from exercise is that exercise also often has an end goal, right? Like maybe someone is trying to improve on their speed or improve on their endurance or improve on their ability to perform a certain type of movement within the sport for which they're exercising. So hopefully that's not too confusing, but again, physical activity is the umbrella term. Leisure time physical activity falls within that category. Activities of daily living fall within this category. And exercise is a type of leisure time physical activity that is planned, purposeful, and structured, and usually with a goal in mind of improving one's skill set. So now we talk about physical fitness. So physical fitness is an ability. It's our ability to carry out daily tasks with vigor and alertness and without fatigue. So physical fitness is not, it's not an activity so much as it is our ableness. How able-bodied are we to do these activities of daily living, to do recreational activities, to engage in some sort of exercise training. So physical fitness has four components. So these are just basically different aspects of a person's physical body. and their abilities. So the abilities of these different physical parts of the body. So we have cardiorespiratory fitness, cardio meaning heart, respiratory meaning the lungs. So lungs and cardiovascular system, heart and blood vessels. So that's, we can have fit or able heart, blood vessels, and lungs and airways. Then we can have musculoskeletal fitness. So this is referring to the ability, right, or even the strength of our muscles and as well as our skeletal system. So also bones and joints and tendons and ligaments. And then a third component of physical fitness is flexibility, right? So being able to, reach really far up overhead, or to bend over, right? Or to, step up on a high step if you needed to for something. So having the flexibility of your muscles to be able to do sort of larger, broader movements is part of physical fitness. And then body composition is actually the fourth component of physical fitness. So it's less an ability, but more a reflection of the makeup of a person's mass. Right? So again, remembering body composition from chapter 13, this is basically a person's total fat mass relative to the person's lean tissue mass. And lean tissue would be encompassing both bones and muscles. So it's a comparison of how much fat mass or how much adipose tissue is on the body relative to how much lean mass is on the body. And certainly having a healthy amount of fat mass would allow a person to be more physically fit. And of course, having enough muscle mass also would allow for physical fitness. Then there are three types of training, or three types of physical activities, I guess we could say, that we can do to build or support or maintain physical fitness. We can do aerobic exercises, we can do resistance or strength training, and we can do stretching. So we'll talk about these on this slide. So I guess, what this chart does is it takes the four components of physical fitness: cardiorespiratory, musculoskeletal, flexibility, and body composition. And then it shows you how, or gives examples, I guess, of different types of activities that we can do to maintain or support or build fitness in these different aspects of the body. So to build cardiorespiratory fitness, we should do aerobic-based activities. So that includes things like walking, running, swimming, cross-country skiing, I guess, or cross-country running. Oh, I see. Maybe they meant to say cross-country skiing. That's why skiing is down here. So cardiorespiratory, basically anything that requires, any activities that require oxygen to perform. That's what aerobic means. So that's where your respiratory rate, or the rate at which you're breathing, would increase. So anytime your respiratory rate increases for the extended period of doing the activity, then you know that that is likely an aerobic type of activity. So usually it's some sort of activity that you do for an ongoing period of time, like 10 minutes or longer, that elevates your respiratory rate for the entire duration of that activity. Then musculoskeletal fitness, there are different types of activities we can do depending on whether we want to affect musculoskeletal strength or musculoskeletal endurance. So for musculoskeletal strength, we can do weightlifting or resistance training. And for musculoskeletal endurance, we can still do weightlifting or resistance training. The difference is that for endurance, you're going to use lighter weights and more repetitions. So, right, you're going for endurance. You're trying to improve the length of time that your muscles can perform this activity. Whereas for strength, we would use heavier weights and fewer repetitions, right? Because you're trying to achieve the maximum amount of weight that part of your body can lift or move or work against. So for musculoskeletal fitness, we're going to use resistance training, and that can be through weightlifting. It can be through calisthenics. This would basically be like body weight exercises, sit-ups and push-ups. So anything where you're really working on the physical strength of the muscles. And then you can also use those resistance exercises to build muscular endurance by using the lighter weights with more repetitions. Flexibility, so we can affect flexibility basically through stretching exercises. Yoga classes are pretty common these days as a means of improving flexibility. And then body composition, we can improve body composition basically through improving cardiorespiratory fitness and musculoskeletal fitness. So a combination of both aerobic exercises and resistance training will help improve body composition. And when we say improve body composition, I mean increasing lean muscle mass and decreasing fat mass to a healthy level. So what are some of the benefits of physical activity? Why do we talk so much about it? Why is it so important? So I guess for every aspect of our lives, really for every aspect of our health, our physical activity and our physical ability, our physical fitness will affect the physical fitness of our overall health. Even just circling back here, when we say that cardiorespiratory is a component of physical fitness, we've already talked a lot about the cardiorespiratory system in this class, right? We've talked about cardiovascular disease. We've talked about how our nutrition can affect the progression of cardiovascular disease. And we've talked a lot about how being overweight can be an additional risk factor that basically makes it such that the body is already under a lot of stress, under a lot of pressure, so that the development of disease actually is easier. It's more likely to occur. So when we are physically active and when we are working on our physical fitness, we are literally improving the healthfulness of our cardiovascular system. So we're reducing the risk of any diseases of the heart or of the cardiovascular system. So reduce the risk for heart disease, stroke, high blood pressure. We also reduce the risk for many other metabolic diseases because we're improving the overall energy usage of the body. So we reduce the risk for obesity and type 2 diabetes. We might reduce the risk for certain types of cancers. We're working on our musculoskeletal fitness, so we reduce the risk for bone disorders and osteoporosis. And then there are a lot of cognitive benefits that come about from exercise too, which I think are exciting and somewhat impressive even. So maintaining good physical activity, maintaining good physical fitness, we can actually improve both the duration and quality of our sleep. We can improve our memory and even our cognitive skills, so kind of our thinking and our reasoning. Our immune system can improve. And then here are some mood-related issues. So by being physically active, we see a reduction in anxiety, a depressed mood, and a reduction in overall cognitive stress. So many, many benefits throughout the whole body. This is a fun figure from your book, 14.1, basically just goes over, I think pretty much everything we said there. Maybe one that wasn't on that last page was your lungs are also going to get healthier, right? Because we're working on cardiorespiratory fitness. So your lung efficiency and capacity can increase. Yeah, so that's just a fun review. You can check that out on your own time if you like. So in the United States, unfortunately, this is probably not news to most of us, we are pretty inactive. And this is true around the world increasingly too. As we become more developed, our lives have become a lot more sedentary. So I think these numbers are also a little dated, probably from around 2010 or so, but suggesting that just over half of all of Americans actually meet the national health recommendations for physical activity. So that means just about half of people in the United States are not active enough. And it suggests that only about less than a quarter of people in the United States meet the recommendations for both aerobic and resistance training exercises. So on this page, I have what those guidelines are. So these are guidelines for just maintaining healthy body weight. And there are 3 different guidelines that I've listed here. The one from the Department of Health and Human Services, which also comes with these guidelines here, also come from the American College of Sports Medicine. These are the ones that I would focus on. We had earlier guidelines from the Surgeon General back before the turn of the century, which was to do about 30 minutes of exercise, 30 minutes of physical activity most days of the week. In 2002, the Institute of Medicine, which is now the National Academies of Sciences, who write our dietary guidelines, who write our dietary reference intake values, they suggest we should be doing 60 minutes a day of moderate intensity activity. And then the Department of Health and Human Services with the American College of Sports Medicine most recently suggest that in order to maintain a healthy body weight, we need to do aerobic activity, and that can be either 150 minutes per week of moderate intensity aerobic activity or 75 minutes per week of vigorous intensity aerobic activity, or a combination of these 2 things, in conjunction with doing muscle strengthening activities at least 2 days a week. So now you can kind of toggle back to these statistics and ask yourself, are you meeting these guidelines for physical activity? Are you engaging in some combination of moderate intensity aerobic activity and vigorous intensity aerobic activity to meet these weekly minutes, 150 or 75, and doing muscle strengthening activities at least 2 days a week? So you can see where you fit in terms of achieving these guidelines. So let's jump back to physical fitness, because I have a bit to say there, especially around to kind of talk through this concept of moderate intensity and vigorous intensity aerobic activities. What exactly does that mean? So for physical fitness overall, there are a few things to say in terms of how do we work on improving physical fitness. So a first step would to be assess where you are currently. Assess what your physical fitness is currently. Assess how frequently you're doing physical activity right now. Are you doing any strength training during the week? Are you doing any vigorous intensity aerobic activity during the week, or moderate intensity? So kind of find your current baseline. A second step would be to see if you have any activity goals. Are there any things you'd like to actually work towards? Because if you do have goals, then there are going to be specific exercises or specific activities that you would engage in to work towards that goal. Also, having goals can sometimes help keep people on track in terms of engaging in physical activity on a routine weekly basis. And then a third step would be to actually make an exercise program. So write out a plan for engaging in physical activity so that you can, do those activities on a weekly basis and ultimately improve your fitness. When writing an exercise plan, I think really important to try to keep it, diverse, keep some good variety in there. Also make it consistent. So if you can, try to schedule the same days each week, maybe the same times each week. Also make it fun, right? Like maybe involve an exercise partner. Definitely do activities that you enjoy. Maybe, do put on some music, or depending on what you're doing, if it's not so enjoyable, I guess if you needed to engage in some screen time, you could watch a movie or a TV show while you're doing some exercise, or better yet, get outside, because usually doing the exercises outside is going to be more fun than just doing them inside on a machine. So with the exercise program too, you might want to think about what motivates you. so that we are motivated by both intrinsic and extrinsic factors. Intrinsic meaning things that come from within. So thinking about why your physical fitness is important to you. Why is your cardiorespiratory fitness important to you? Why is your musculoskeletal health important to you? Right? So those would be some intrinsic factors. Also, just thinking also about the type of activities you like to do. You'll be more intrinsically motivated to do activities that are fun for you. And then extrinsic factors are things external to you that motivate you to engage in the activity. So again, having goals could contribute to extrinsic motivation, right? If there's some event that you're kind of working towards so that you can compete or perform at that event, or if you're kind of, again, doing it with friends or family members, having that sort of friendly competition amongst you, but also having them to motivate you to engage in your exercise program week to week. Okay, so those are kind of the first things to consider. And then once you actually write your exercise program, the thing that you would be writing, or if you also sought out help from a personal trainer or an exercise coach, an important component of the exercise plan would be this overload principle. So overload is where we basically stress our muscles and stress our bones and joints. So we stress the musculoskeletal system, and depending on the exercise, we may also stress the cardiorespiratory system. So the point is to increase the demands and put some stress on these systems, these body systems, so that we can improve. So it's usually a small little increase in stress, or your book says demands, on these different body systems in an appropriate fashion so that your body can gain in muscle size or strength. So hypertrophy is basically the benefit that occurs from overloading your muscles or your different body systems, right? An important caution with overload, however, is that we can inappropriately overload our bodies, and that can lead to exhaustion, excess stress, and injury. So there's a really fine line that we all have to find with this concept of overloading, because we do want to overload. That's the point actually of exercise, is to put slightly higher demands on the body, on your heart, your lungs, your muscles, your bones, so that they can recover from that stress and actually gain in size, strength, and endurance. And so that's basically what hypertrophy is. Hypertrophy is specific, though, to muscle size and strength. Also in your fitness plan, using the FIT principle would be really helpful and arguably important to write an appropriate exercise plan. So we'll talk about the FIT principle on the next page. And then also your fitness plan should include a warm-up period and a cool-down period. So when we talk about hypertrophy, I think it's helpful to also mention the opposite of hypertrophy, which is atrophy. And atrophy is basically where your muscle size and strength diminish or decrease. And this happens when we don't work our muscles adequately enough. Maybe you've had the experience of like being in a sport and like feeling that hypertrophy over the course of several months. As you improve in the sport, you feel like you're gaining in strength, you feel like you're gaining endurance, and then maybe the season ends and you don't do it, you stop doing anything, and then it's another 6 months before that season starts back up. And at the start of the season, you're always feeling a little weak and a little slow and not as strong as you were at the end of the season last year. So what's happened in that time when you've been away from your sport is your muscles have atrophied, right? Their strength, their ability has decreased because they have not been worked properly. Also injury, if you've ever suffered an injury or know somebody who has, where they've either been in a cast maybe, or they've just been unable to use a certain part of their body, a leg or an arm, or even a hand or a foot, and say they can't use it for a month to several months, you'll notice that the muscles of that part of the body will decrease in size and strength because they haven't been used. that's muscular atrophy. Okay, so the FIT principle. So FIT is an acronym. FIT stands for frequency, intensity, time, and type. So frequency is simply the number of sessions that you're going to engage in physical activity per week. Intensity is the amount of effort that you're going to expend during those activities. And we'll talk about intensity on a few more slides. Intensity is usually characterized as either low, moderate, or vigorous. And also heart rate is often used to indicate level of intensity. And then time of activity could be both how long a session of activity lasts. It could also be literally the time of day in terms of planning, but typically it refers to how long a session lasts. And then type is what type of activity are you going to do? And then the type of activity, just referring back to the earlier chart, would depend on which body systems you want to affect. So whether you are trying to affect cardiorespiratory fitness, musculoskeletal, or flexibility. So a little bit more about intensity. So we have low intensity, moderate intensity, and vigorous intensity. I just wanted to give some little more description to these, as well as some examples. So low intensity activity would cause very subtle increases in breathing, sweating, and heart rate. All right, that would be things like light household cleaning, a casual walk outside, like for most people that would be like dog walking. Moderate intensity activities, this is going to cause a moderate increase in breathing, sweating, and heart rate. Sorry for the typo. So how do we qualify that, right? How do we qualify moderate increase? So I think a helpful piece is to always go by your ability to have a conversation with somebody. So in moderate intensity activities, we can have a conversation with somebody if we're doing the exercise with them, but not continuously, right? So you would maybe need to take a break from talking for a minute to catch your breath back up. So for a lot of folks, this would be like a brisk walk, or maybe something like doubles tennis, or riding a bike, but again, relatively casually. And then vigorous intensity activity would be more than that. So you'd see a significant increase in your breathing, your sweating, and your heart rate. So this would basically be like, you can probably say, 3 or 4 words at a time, but having a conversation would be pretty difficult. So for a lot of folks, this would be like jogging or actually running, playing singles tennis, doing other types of aerobic sports or an aerobic workout video. Jumping rope would be a good example of this. And then on this slide, I just kind of bring this concept of heart rate into this conversation about intensity. So low intensity activities, we would say that your heart rate stays relatively low. But for moderate and vigorous intensity activities, we say that the heart rate increases towards our maximum heart rate. So in a vigorous intensity activity, we get pretty close, like even 85% of the maximum rate at which our heart could possibly beat. So vigorous intensity activities, our heart rate is elevated to the point where it's beating at about 70 to 85% of its maximum capacity for beating. And then moderate intensity activities, the heart rate is elevated to about 50, maybe up to 70% of the maximum heart rate. So maybe I could have swapped the order of these things. So what is max heart rate? Maximum heart rate is, again, the rate at which your heart beats during its maximal intensity. So it's literally the fastest your heart could beat. You can actually do some like physiological tests, or it is possible to do, but usually only like exercise physiology research labs have the equipment needed to perform what would be called a maximal exercise test. So in lieu of doing this test to actually see what your max heart rate is, we can get a pretty good estimate of max heart rate by taking this number 220 and subtracting your age in years. So if you are 20 years old, easy math, your max heart rate is probably around 200. And this is heart rate, so we're talking about beats per minute. So if your max heart rate is 200, a moderate intensity activity would be something where your heart beats at least 100 beats per minute, half of your maximum heart rate. And a vigorous intensity activity, your heart would be beating at least probably 150 beats per minute. This would be another helpful figure in one of your upcoming labs. I actually ask you to write out a program for yourself. You don't have to do it, but just practice writing one. So again, frequency, intensity, and then time and type. So this chart writes it out per type of physical fitness that is trying to be achieved. You can certainly do that too for your lab report, but it's not required. I actually just want you to at least put the fit pieces together. But as you saw from the guidelines for physical activity, it is suggested that we engage in all 3 cardiorespiratory, musculoskeletal, and flexibility exercises each week. This is just a heart rate training graph. So we're sort of showing you on the y-axis is heart rate, on the x-axis is age, and it's just showing you sort of the optimal training zone based on heart rate. This is moderate intensity, right, between 50 and 70% of the maximum. And then here's showing like max heart rate, obviously declines as we age. And then again, the last 2 pieces of a successful training program would include warm-up and cool-down. So warm-up are exercises that are done, or movements, I should say, that are done before the actual exercise. And there are several purposes, several reasons for doing warm-up activities. So basically, they prepare your muscles for the activity by increasing blood flow to that part of the body, literally warming up the muscles, and again, preparing them for the exercises that you're going to put them through. Warm-up can also enhance flexibility, and it can also be a helpful preparation psychologically to sort of get you in the state of mind to do the exercise. So warm-up movements should be brief, they should build gradually, and they should be relatively gentle, right? You might be going from like sitting for 8 hours or sleeping even, and so before engaging full out in the exercise, actually gently warm your muscles up and then go into the exercise. And then cool down is kind of the same, but performed at the end of the exercise. These again should be done slow and gradually. And the point of cooling down is, again, there are multiple reasons for it. One of the most important pieces, I think, is that it can be a really important way to prevent injury. And it can also reduce muscle soreness post-exercise. Cool down activities generally include stretching, whereas warm-up activities usually involve more movement-based activities. So you might kind of move your muscles through their full range of motion, but slowly and gradually. Whereas in the cool down, you might actually include some static stretching where you're sitting still, or you're still and holding the stretch for 15, 30, or 60 seconds. And the cool down, you might even include, actually in both directions, warm up and cool down, you might actually include some of the exercises that you plan to perform in the exercise period, but just doing them at a lower intensity. Alrighty, and then just kind of an interesting sort of put together of ideas for how any person could be more physically active. So this is physical activity, right? This is the umbrella term. These are all of the ways in which a person could just move more throughout their day. So taking the stairs instead of the elevator. In these days, we're on our computers so much. So taking regular breaks every hour, every 2 hours, get up, stretch, walk around, take some fresh breath, take a step outside and get some fresh air, a breath of fresh air. I think that's what I'm trying to say. right, 5 minutes, just get up and get moving, get some blood flowing. Again, there's that idea of exercising while you watch TV. If you have to watch TV, right, maybe involve a little bit of movement or stretching while you're watching TV. When you can, for like everyday, activities or chores, if you can, move around while you do the activity. If you're talking to somebody on the phone, can you be out for a walk, or can you be kind of putzing around your house at least? Again, plan more intentional activities. Do it solo or do it as a group. Also, when we get back to vacationing, maybe try to plan some physically active vacations, like plan your vacation around physical activities that you want to do. It can be fun too to use step trackers. Most phones these days come with a step tracker. And now we even have a lot of those smart watches that actually track heart rate. So that can be fun too. And it's, relatively simple technology. It's not necessarily affordable a lot of the time, but if you have one, then it's right there with you all the time. You can kind of constantly check in and see, or at least regularly check in and see how many steps have you walked, how often in that day have you elevated your heart rate above resting. So just some ideas, again, around increasing overall physical activity. So now we're kind of starting the second half of this lecture, which gets into, kind of brings together nutrition and physical activity. So when we talk about nutrition and physical activity, we could, in other words, say, how do we fuel the physical activity that we're going to do, especially something like exercise? So you might remember ATP, adenosine triphosphate. This is the sort of energy currency of the body, right? So in order to produce the movements of the skeletal muscles, we need to utilize ATP. We need to have ATP available. So one thing we haven't said about ATP is that muscles typically store a tiny bit of ATP. The muscles generally always have about 1 to 3 seconds worth of ATP available at any given moment, or at least I should say at rest. So like if you've been sitting here watching this lecture and then at the end of it you get up and you walk around, those first 3 seconds of like getting up out of your chair and moving around are going to be powered by ATP that's just living in your muscles. So once we use up that ATP, then we have to make ATP, especially if the activity is going to continue for an extended period of time. So say this lecture ends and you're going to get up and go for a walk because it's a nice day, your body is going to have to make ATP for the entire duration of that walk, or all of the muscles that would be involved in walking. So you might remember from our conversation about metabolism that we can make ATP from the breakdown of carbohydrates, fats, and in the case of starvation or poor nutrition, from protein. But we're going to focus on carbohydrate and fat production of ATP in this lecture because carbohydrates and fats are the 2 primary fuel sources of the body and the 2 fuel sources that your body wants to use during physical activity. Kind of a little review chart, but showing anaerobic metabolism and aerobic metabolism. Remember, anaerobic is that short period of ATP production that occurs outside of the mitochondria, so it occurs in the cytoplasm of the cell. And this is metabolism or ATP production that happens without oxygen. So it's in aerobic metabolism that we have oxygen. And aerobic metabolism happens inside the mitochondria, and that's where we have acetyl-CoA moving through the Krebs cycle, and then all of those coenzymes working in the electron transport chain to produce ATP. So after we deplete those few little ATP stores for those first 3 seconds of exercise, then we will turn to our other substrates for making ATP. There's this new one that we haven't talked about yet called creatine phosphate. So we'll use creatine phosphate to make a little bit of ATP, but that's only going to provide about 3 to 15 seconds worth of energy. And then after that, we're going to turn to carbohydrates. And then depending on the type and the duration of the activity, we will turn to fats. So I think I have a creatine phosphate here. Yeah, creatine phosphate is pretty simple, right? Your muscles always store a little bit of creatine phosphate too, and it's literally this creatine molecule attached, I should go here, this creatine molecule attached to a phosphate group. And so when we break the creatine and the phosphate apart, that actually releases a little bit of energy itself, and then the phosphate is available to bind to adenosine triphosphate and make ATP. So the energy released from the breakdown of creatine phosphate is actually what helps support the building of ATP. So basically creatine phosphate donates this phosphate group ADP so that we make ATP, and then ATP can be used to power the work of the muscle cells. So after we use up creatine phosphate, actually let me go back here, sorry. We only have enough creatine phosphate, again, to power like 3 to 15 seconds of maximal physical effort. So we really only use creatine phosphate for intense, brief activity bursts. So this would be like, I don't know, your dog got out of the house. And so you're listening to this lecture and all of a sudden you hear your dog's barking across the street at the neighbor's house and you burst out of your chair and run across the yard, right? Then you're using creatine phosphate. But if you get up out of your chair and you put on your coat and you go out and you walk, that's probably not going to use very much creatine phosphate. You're probably going to just use those initial ATP stores and then actually turn to carbohydrate breakdown. So if creatine phosphate was used, again, that's only going to get you through about 15 seconds. So then after that, we turn to carbohydrate or glucose to produce ATP. So you might recall that process of glycolysis where we break glucose down and produce 2 pyruvate molecules. And the glucose is available because we have glucose stored in the form of glycogen in the muscles doing the work. We also have glucose in the blood at any given time, which is available to do work. And if you've just eaten a meal, you would have even more glucose available in the blood to do the work of the exercise. So one of the reasons that we eventually turn to fat as an energy substrate is because we actually have limited stores of glycogen. So glycogen, between both our liver and our muscle, we can actually, this is showing muscle glycogen. So yeah, there'd be a little bit more that would also be stored in the liver. But again, the liver is typically reserving glucose for the brain. So we'll focus here on muscle glycogen. So on your average sort of 70 or 140-ish pound person, 70 kilogram or 140 pound person, 150, might store about 200 to 500 grams of glycogen in their body. So that's enough glucose to power about 800 to 1,000, 1,200 calories worth of movement or energy expended. So this would be in a 24-hour period. So depending on the exercise, a person may well be able to do the exercise using just stored muscle glycogen. So for really long duration activities, where the person's exercise might actually need more than 800 to 1,000 calories to support the energy, that's where we start to turn to fat as well. So just a little review of carbohydrate metabolism. Remember, the end product of glycolysis is 2-pyruvate. If we're in an anaerobic state, so that would typically be like weightlifting or resistance training, we're going to see a little more lactic acid buildup. Lactic acid is really interesting because it actually will circulate back to the liver and then get converted back into glucose and then used for energy once oxygen becomes available. So you might remember anaerobic, again, is just that little part, is just that glycolysis part. It yields a very small amount of ATP, and that's because of sort of the shunting to lactic acid. where we don't make as much acetyl-CoA. And then aerobic activity is where we do make the acetyl-CoA. It passes into the mitochondria. We go through the tricarboxylic acid cycle and the electron transport chain, and so we yield quite a bit more ATP during aerobic exercises. This is the Cori cycle. So this is showing how we recycle lactic acid or lactate after exercise, and once we've regained enough oxygen to utilize pyruvate more effectively. So during an intense exercise, so again, this would be like resistance training or, a really intense, vigorous activity, vigorous aerobic activity like running really hard or riding your bike really hard. We're going to have glycolysis, but then we won't be able to make acetyl-CoA. So pyruvate will get converted to lactic acid. And then after the exercise, the lactic acid from the exercise will get converted back to pyruvate. And then because okay, sorry, let me go over here to the liver. The lactic acid will get converted back to pyruvate, and then, okay, it's not shown here. I thought it was. Depending on what the body needs, the pyruvate can actually be converted then to acetyl-CoA and used for energy if needed. So say this is after exercise in the cool down period, your body's still moving, still active, you're still using energy. So the lactic acid will be converted back to pyruvate. If the body's still using energy, that pyruvate would then get converted to acetyl-CoA and used as energy. And that would probably take place here in the muscle. But if say it's like the total end of the day and now you're going to sleep, if there's any lactic acid still floating around, then your body's going to convert it all the way back to glucose and just store that glucose as glycogen back in the liver or back in the muscle. Okay, and now onto fat. So fat we really only use for low intensity, long duration exercises. So a classic example would be running a marathon, right? That's 26.2 miles. People may be out there for several hours at a time. And probably everybody except the elite athletes who are actually racing the marathon, probably everybody else out there would be in this state where they're burning both glucose and fat to provide the ATP to do the running. So one of the reasons that we only use fat for low intensity, long duration exercises is because that process of beta oxidation is really slow. You might remember that, if you remember that fatty acid carbon chain, remember we said that there are so many more carbons in that chain relative to a basic glucose molecule. And so because of that, we get so many more calories per gram of fat than we do per gram of carbohydrate, right? More than twice as much. But this is a much longer chain, so it just takes longer to break down. But that's why it's a perfect fuel for long duration, low intensity exercises. This would also be like somebody who's going to go out and hike for half the day, 4, 5, 6 hours. Their body's going to be burning a lot of fat to do that exercise. Fat is also interesting because even healthy weight people, people with healthy body composition, healthy BMI, whatever, we store fat. We just do. We always do. So we always have fat available. Whereas if I toggle back here, remember we have a limit to the amount of glycogen that we can store. But we can store basically endless amounts of fat. Also really important for you to note, this usually comes as a test question, fat is, again, because it is such a slow breakdown process, it is actually the primary energy substrate that we use during rest, during periods of extended sitting or standing in place, and again, also during endurance events. So throughout the nighttime, when you're sleeping, a lot of that energy is powered by fat. And again, if you have a desk job or if you are spending a lot of time doing your schoolwork on the computer these days, those extended periods of really low intensity activities are primarily fueled by fat or triglyceride. So a little review, carbohydrates and fats are both used as a source of ATP to provide energy for exercise. Carbohydrates we use especially for high intensity activity, and fats we use pretty much only during low intensity exercise. And then remember that proteins are not a major fuel source for exercise. We can use protein as a fuel source during times of starvation, but not during exercise. That would not be good if your body's using amino acids as an energy substrate during exercise. Also, I think a really fun chart, focus figure 14.7 in your book, basically goes over all these different running types. So from a short, just the start of your sprint to a 100-meter dash, to just shy of a 1-mile race, to about a 6-mile race, the marathon, or a full day of hiking, right? 6 to 7 hours. And what it shows you is the different energy substrates that are utilized for these different activities. So again, that sprint start, those first 3 seconds, you're actually using the ATP and the creatine phosphate stored in the muscles. For a 100-meter dash, well, 10 to 12 seconds if you're an elite athlete, you're going to be using, right, the first half of that is going to be ATP, creatine phosphate, and then the back half of that's probably going to be carbohydrate. A 1-mile race, going as fast as you can. For 1 mile, again, you're going to start with that little bit of ATP, creatine phosphate. The rest will be fueled by carbohydrate. In a 6-mile race, you're still going to be primarily carbohydrate. You might not even use the creatine phosphate, depending on how quickly you get out to start the race. And then you will start to use some fat burn there. Then in the marathon, you'll start to use some fat, still a good bit of carbohydrate. And you'll see here 5% other. So in this case, you'll notice here it says a very small amount of energy is provided by the breakdown of amino acids to form glucose. And that's effectively because in a marathon, people are going for so long at a relatively high intensity that it's pretty common to actually see a little bit of muscular breakdown to support the energy of that exercise. So not great, but that's how it happens. And then the day-long hike. So again, this is low intensity, long duration. This is where we see the majority of the exercise being fueled by fat, and then obviously still some carbohydrate. We really wouldn't see any potential for protein breakdown here because it's going at such a low intensity. Sort of saying the same thing, just in chart and graph form. So this is looking at the percentage of contribution to the energy for the exercise, for carbohydrate and for fat, based on the intensity of the exercise. So as the intensity increases, we use more carbohydrate. As the intensity is lower, we use more fat. And then same thing over here. So low intensity, we kind of use a split of carbohydrate and fat. At moderate intensity, we're still going to use some fat, but you start to use a little bit more carbohydrate. What else can we say here? So that's just, so far we've just talked about the energy substrates to fuel these activities. Now we can say a little bit more about how much is needed of these different nutrients. So really important to note that for most people, just following the healthy dietary guidelines that we've already talked about is enough to fuel daily physical activity. When we engage in vigorous intensity exercise, our energy needs will likely increase. People who would be considered athletes tend to have higher energy needs than people who are just, casually engaging in recreational activities. Males and females have different energy needs. That's primarily based on body composition and body size. And of course, the type of physical activity requires different substrates too, which we just saw right here, right? Somebody who's practicing sprinting has very different energy needs than somebody who's practicing hiking. This is a good chart just to review. Let's see if I want to say anything on here. I'm going to say a lot of this on the next page. But yeah, so right, carbohydrate is for energy, fat is for energy, protein is for building and maintaining muscle. It can be a source of energy during endurance exercise. Of course, it aids in muscular recovery from the exercise. Fat is also important because it's the source of getting our fat-soluble vitamins. It's also a source of our essential fatty acids that reduce inflammation. Fat's also important because we use fat to build hormones and other nutrient transportation. Carbohydrates, yeah, pretty much an energy substrate. Remember to be choosing complex carbohydrate foods because they're also going to provide vitamins and minerals. Water, we're going to say a lot about water coming up. And then a couple micronutrients, I guess, B vitamins, calcium, and iron. We did talk about these also in chapter 13. So this would just be a review of why these are so important during exercise. Again, B vitamins are part of supporting metabolism. Calcium is for that bone health, also for muscle contraction, nutrient transport across cell membranes. And iron, of course, is for oxygen carrying in the blood. And then you can revisit the recommended dietary allowances. So you'll notice here, these are the AMDRs for our macronutrients. So anybody who's engaging in sport should still generally fall, their dietary intake should still generally fall somewhere in these categories. 45 to 65% for carbohydrate, 20 to 35% for fat, and 10 to 35% for protein. If you toggle back again here, and I know this is just running, these are just different running activities, but it makes sense. The nutrient used most is carbohydrate. The nutrient used next most is fat. The nutrient used next most is protein. So that's part of why these numbers fall in this way. This range here, you might have noticed, is different from on the table here. On this table, it says protein suggested intake is 1.2 to 2.0 grams per kilogram of body weight. Oh, I'm sorry, that's the same. I'm sorry. I looked at that twice and I swore they were different. So this is, oh, it is different. The other page said 1.2. So yes, I guess I would go with this range. It's a little wider range. Definitely for athletes, you probably do want to be more in this 1.2 at least and upwards. People who need 2 grams of protein for every kilogram of body weight, that's much more for people doing muscle building activities. So really focusing on strength building and actually building the volume of their muscles. For anybody else who's kind of more focused on just healthy balance of all the exercises, you'll probably fall more in that 1.0 to 1.2 grams of kilogram per body weight. After we exercise, obviously we've said already that we do need protein to support muscle synthesis. We also need carbohydrate to actually fuel that muscle synthesis. Also, after exercise is a good time to replenish your glycogen stores. So those first 4 to 6 hours after an exercise are a critical time for rebuilding glycogen stores. Again, with carbohydrate, with all food, it's important to choose healthier versions, right? So choose complex, non-processed carbohydrate foods. So whole grains like oatmeal, brown rice, wild rice, quinoa. Choose whole fresh fruits or frozen fruits. Choose whole fresh vegetables or frozen vegetables. These are also going to provide you with fiber, vitamins, and minerals, as well as the carbohydrate. As always, take a look at this. This one is interesting because it's actually just showing you, these are both like relatively healthy meals, but this is just showing you if you needed a lot more calories to fuel the exercise. More energy for more activity. So I guess just a little bit here about low carbohydrate diets. So these have become really popular. This is obviously, again, a chart from your book. It's basically just showing that on a low carbohydrate diet, you're going to totally deplete your glycogen stores. I suppose hopefully that's pretty straightforward. Yeah. So this is showing 3 days in a row of doing a 2-hour cycling activity. So after the first day, say you've got somebody on a high carb diet and somebody on a low carb diet. After the first day, obviously you're going to deplete your glycogen stores. But if you're eating healthy, not even high carbohydrate, but just in that healthy AMDR range, well, then you're going to eat to replenish your glycogen stores. So the next day, you might have slightly lower glycogen, but you've done a pretty good job of replenishing. Like say this was a 3-day cycling event, 3-day race or something. And then this person who's doing a low carb diet, obviously they weren't replenishing their glycogen stores. So after the next cycling activity, obviously decrease your glycogen. Again, high carb is going to build glycogen stores, low carb is going to further deplete it, and on and on. So what this is showing you is that somebody who's following a low carbohydrate diet will likely have a lot of trouble at these, actually this is a good one, at these higher intensity activities, right? The less glycogen you have, the less glucose you have available to fuel higher intensity activities. Again, just an FYI or for your reference, different foods showing you the carbohydrate amount and the total calories. A little bit about carbohydrate loading, also called glycogen loading. So if you did do sports in high school or even now at the college, this is a pretty common practice, although it's actually not always practiced correctly. So carb loading is meant to maximize glycogen stores prior to an event or a competition. The thing is, it's an actually 6-day process, and most people just kind of stuff themselves with pasta 12 hours before the event. So that's not the same thing, although we call it the same thing. So what is carb loading actually? So it's a 6-day period of changing both the amount of carbohydrate you're eating and actually the exercise duration, and it's altering it. So I'll show you on the next page. We've got a chart that shows you the 6-day process. For some people, they may find some GI distress. They might not actually find that it works well. For some people, it seems that it does work well and does improve performance, but really it kind of depends on the person, and I think also depends on how well the glycogen loading is actually performed. So here is your 6-day chart. So here's 6 days prior to the event. You'll notice on the right side, this is the amount of carbohydrate the person would be eating. So and then in the middle is the exercise duration with the intensity. So what's interesting is you have these first 3 days of carb loading. So day 6, day 5, day 4 prior to the event, you're actually carb depleting. So you're going at your maximum intensity with low carbohydrate intake, low to moderate intake. So these first 3 days are actually basically this. Right? So you're actually totally depleting glycogen stores. And it's in these 3 days that a person might feel really sluggish and potentially having some GI distress. And then in the 3 days just prior to the event, you really pull back on the intensity of the training and you increase the glycogen intake. So the thinking here is that by depleting glycogen stores and then having 3 days to increase glycogen stores, by the day of competition, you might have achieved a sort of maximum glycogen capacity in the muscles. Again, obviously it's kind of a lot of work, or it takes a lot of intention and focus, and it doesn't necessarily work so well for everybody who does it. A little bit about training and fat metabolism. So the more trained we are, the more efficient we become at using fat as an energy substrate. So more highly trained athletes actually have more enzymes that work in the process of fat metabolism. Also, we see that highly trained athletes actually store more intramuscular fat, because that way the fat is there and available to do the activity rather than having to pull it from adipose tissue. We also see that highly trained individuals are better able to pull fat from the blood, and also have sort of a higher capacity for carbohydrate sparing, even at times of intense exercise. So it's kind of cool. As you train your body physically for strength and endurance and whatnot, you can also train your body for improved metabolism, and especially improved fat metabolism. A little bit more about protein needs. So not really on here. I guess, again, protein needs are most important for recovering from the exercise, because if we go all the way back to the beginning of the chapter, we said that the point of exercise is to overload the muscles, overload the cardio respiratory and the musculoskeletal systems. So we're literally stressing these systems, and at the end of the exercise, we want them to recover from the stress so they get stronger. So protein is really important following exercise. And depending on the exercise, it might even be important to take some protein in just before the exercise too, to make sure there's some immediately available upon finishing the exercise. So depending on the type of exercise, we may need even more protein. Remember, we said basically 1.2 to 2.0 grams of kilogram per body weight. So people who are engaging in really competitive, high endurance, or high intensity athletics will have an increased protein need. So they will sit farther on this end range. People who are just sort of recreationally being active probably already consume enough protein and shouldn't worry about increasing it. Again, choose protein from healthy food sources. So definitely include some beans and lentils, some nuts and seeds, also poultry, fish, and eggs, rather than red meats. And then again, basically follow the recommendations that we've talked about already from MyPlate and the dietary reference intake values. Now, water. We have a lot to say about water. Water is really critical. I know we've talked about water already. Now we'll talk about it specific to exercise. So a little review of what water does, right? It lubricates all of our tissues and cells. It is plasma of the blood is made up of water. So it's a transportation system for nutrients, hormones, as well as waste products. We know that we use water in chemical reactions and we produce water in chemical reactions, right? Hydrolysis and dehydration synthesis. We know that water makes up a lot of our body tissues, right? We've talked about intracellular and extracellular fluids, and we use water to make proteins and glycogen. Also, of course, water helps with temperature regulation. We already talked about evaporative cooling. So with exercise, there are a lot of potential, illnesses that can come related to the exercise and the hydration status. So we'll talk about a few here. There's something called heat syncope, heat cramps, and heat exhaustion or heat stroke. So heat syncope is basically a dizziness caused by being physically active, not necessarily exercising, but even just being physically active in a high temperature and being somewhat dehydrated. Heat cramps is where we have these muscular spasms or these like the muscle seizes up and doesn't relax. That can also be caused by dehydration. And then we have heat exhaustion and heat stroke, which can actually be quite serious and sadly even fatal. So heat exhaustion is where we've had so much sweating, right? We've been exerting our bodies for a long period of time in the heat. So we've had a significant amount of water loss, which leads to feeling weak, dizzy, nauseous, definitely having cognitive impairment. So headache, difficulty concentrating, potentially even forgetting a little bit about who you are or where you are. And so this is a very serious condition. Medical attention should be brought to the scene immediately to support the person. And again, if this person is not supported, death is definitely a possibility. So you would treat this by getting the person out of the hot environment if possible, trying to cool their body down, potentially putting, wet, cold towels or blankets on the person, and then helping them slowly rehydrate with water and electrolytes. Same with heat syncope and cramps. You could treat those two the same way. Again, possibly cooling the person from the outside, but also providing fluids and electrolytes to drink too. So symptoms of dehydration during heavy exercise, lots of things, right? So you might see like a decreased sort of ability to perform the exercise. It might feel like you're working harder to do the exercise. Heart rate might go up. You might feel a decreased appetite. Again, difficulty concentrating, definitely that fatigue, weakness, dizziness, headache. And then with urine, you would see a decrease in urine output and also a change in urine color. Remember, to that sort of dark yellow or even dark brown color. So how do we hydrate properly during fluid? So first of all, everybody should always be trying to drink a healthy amount of water every day. Remember, we said 2.7 liters for females and 3.7 liters for males. So that should be baseline water intake. And then with activity, we should drink more than this. So whenever we're going to do an activity that lasts for 1 hour or less, replenish with probably 16 to 32 additional ounces of water. And that is going to depend on the environment again, whether it's hot, whether it's humid or arid, whether and the type of activity, whether it's a really intense activity or just a kind of a leisurely walk. And then once we start exercising for more than an hour, we should replenish with water and electrolytes and potentially even a small amount of glucose. So this would all, again, depend on the duration of the activity, the intensity, the environment, how fit the person is, how acclimatized they are to their environment, and how much they're sweating. So it's really important to drink fluids before, during, and after exercise, not just one of these, right? As I said, always maintain your baseline proper hydration. Drink more during the activity, drink more after the activity. Relying on thirst alone is not a good mechanism, right? As we just saw here, you may feel a reduced appetite. You may actually feel a reduced perception of thirst even. So relying on thirst is not a good way to go. Be very mindful of your activity and plan your hydration ahead of time. This is a helpful chart for trying to figure out how much fluid to replace with, depending on the activity. So I guess maybe more so based on your activity level in general, relative to your environment. So for people who are active, we should be consuming even more than 3 liters per day. And if you're active in a warm environment, it may be even above 5 liters per day. This just kind of goes over healthy ways to hydrate prior to the exercise, right? Basically, adequately hydrating 24 hours before the event, and then, depending on the event, slowly consuming a little bit of water leading into the exercise. During the competition, try to replenish water as you're going, potentially also replenish electrolytes depending on the intensity and the environmental conditions. And then again, after exercise, consume about 3 cups of fluid for each pound of body weight lost. And you can read the rest of that if you're interested. And then again, a review of some of these vitamins and minerals. So for people who are, really seriously engaging in athletics, you may even consider supplementing with B vitamin, calcium, iron, and magnesium. So again, B vitamin for metabolism, calcium for your bone health and muscle contraction, iron for oxygen carrying, and magnesium also for neuromuscular communication as well as muscular relaxation. So an important one post-exercise. Again, most of this can be met with a healthy diet, but for people who are engaging in pretty intense regular activity, exercise, might even consider supplementing with some of these. And then lastly, in this chapter, we'll talk about ergogenic aids. So ergogenic aids are kind of supplements, basically, that are thought to potentially improve exercise and maybe even athletic performance. So the issue, though, with ergogenic aids is that most of them are not very effective or not as effective as they're touted to be. Many have harmful side effects, they're pretty expensive, and most of them have not been adequately studied to really determine their safety and efficacy. So your book lists a few. These 5 here are all considered anabolic, right? Remember, we talked about anabolism and catabolism. So anabolic is synthesizing. So anabolic products are supposed to be, or they're promoted to be, things that are going to build muscle strength and muscle size. So you have anabolic steroids. These are testosterone-based steroids, generally illegal in the United States. Some of the health consequences include potential development for cancer, damage to the liver, having an unhealthy lipid or cholesterol profile, and potentially even infertility. There's something called androstenedione and DHEA. These are precursors to testosterone in the body. Very little science has been done on these to see if they're actually effective. There's something called beta-hydroxy beta-methylbutyrate, which is a metabolite of one of our amino acids. Again, all these associated with growing your muscles in strength and size. This is one that so far has shown little to no serious side effects. People also supplement with creatine, right? Creatine phosphate. So putting more of that creatine phosphate into their muscles to support those short, sort of explosive movements of 3 to 15 seconds. And then some people also supplement with protein and amino acids. We talked a little bit about these in chapter 13. Again, my suggestion is the best way to get protein and amino acids is through food. A lot of people use protein shakes. Again, a lot of sort of everyday people who've begun to engage in physical activity use protein supplements where they really don't need to, and probably wind up taking in too much extra calories, because most protein supplements come with excess sugar. So these are something that really should be looked at carefully, and I would actually say avoided, except in probably a few specific cases, and really reserved for people who are doing regular high intensity and or long duration exercises, probably 5 days a week or more. Some other ergogenic aids, so the ones on this page are all suggested to increase energy levels. So caffeine, kind of an obvious one, also ephedrine, also carnitine, so again, a supplement. You can take it as a pill. Remember, carnitine is what helps get our fatty acids into the mitochondria for beta oxidation. Chromium, some people supplement with chromium to enhance getting glucose into the cells. Also beta-alanine and sodium bicarbonate. These peeps, I don't know that these are all that common, but when they're taken, they're used to try to support maintaining a neutral pH of the blood and the working muscles. There's also nitrate. This is kind of an interesting one because some of our foods are actually good sources of nitrates. So when we ingest nitrate, we produce more nitric oxide. And having more nitric oxide in the blood actually does show to be effective for improving endurance and sort of tolerance of higher intensity exercises. One of the most natural sources of nitrate is actually just good old beets. So if you like this concept, you can just add more beets to your diet. Also, to my understanding, green leafy vegetables do too in their raw form. So eating more raw kale salads, things of that nature. Okay, I guess that's it. So that's the end of chapter 14. As always, you can scroll through the review questions here. and check your book too, just to kind of review everything in a little more detail. If you have questions, feel free to email me. Thanks all for listening. We'll see you next time.